Okay, IB Geography students, one of the key skills that you need to be successful on the IB Geography exam and to understand the data we'll look for in our class is the ability to draw basic maps and to interpret more complex maps. So to that end, this is our introduction to different types of maps that we will see this year. We'll begin our practice of making maps in class next time we see each other. So the expectation of the IB curriculum is that you can read and create a variety of types of maps by hand and or using computer programs. You will draw maps by hand on your IB exam, and you will create maps probably with a computer program, though maybe by hand, for your internal assessment. So let's talk about different types of maps. A common form of map in the IB curriculum is an annotated map. This takes a basic map of any kind and adds information to it through annotations. Annotations should explain the key features on the map, and the way you do an annotation is to take the point that's relevant, draw a line outside the map, and then write the information. It's very common that annotated maps become too small, they're hard to read, or they're not appropriately labeled. You want to make sure that your maps are clear. When you're creating an annotated map on your IB exam or on your internal assessment, it's important that you not include more notes after the map, right? I wouldn't want a paragraph down here that explained the map. All of my information should be in the annotations. Location maps are the maps that you're used to seeing to get around from place to place. They show the relevant location. You're going to have one of these in your internal assessment, and they need to follow mapping conventions. That means things like north is at the top, there's a scale, there's a key perhaps. All right, let's talk about other kinds of maps. Thematic maps show you data about certain locations, and frankly most of the maps that we'll look at this year are going to be thematic maps. So the first kind is a choropleth map. We'll practice making these pretty soon. What choropleth maps do is create shading or patterns in proportion to some sort of statistic. So this is an event density map for crime in Washington, D.C. It shows us the density of particular types of crimes, and we can look at that in comparison to the population. So the convention for a choropleth map is that the more of something there is, the darker that area of the map is shaded. You can see that we have more population density is the darker purple, and more crime events is the darker blue. Another way of displaying data is with a dot map. This is when you put a dot for each point of data in its relevant location on the map. This one happens to be a dot for every 1,000 college degree holders in the DC metro area. So we can see that there are areas of concentration of degree holders and then areas where there are fewer college degree holders. The problem with dot maps tends to be that if you don't put the dot in the correct place, you may have inadvertently grossly misrepresented your data. However, dot maps can be really helpful because they show us spatial patterns of information in ways that other maps might not. ISO lines show you lines that connect locations of equal value. So everywhere along this line has a 50-inch mean precipitation for the year. So about 50 inches of rain for the year everywhere along this line. Here it's 40, here it's 45. So we can compare the areas based on the lines on the map. Sometimes it's too difficult to pin down a specific line, so we need an area that shows us where things are the same, and that's an isopleth map, right? So it's like a combination between an isoline map and a choropleth map. It shows us areas where the data is all the same. So you can imagine you've expanded those isolines to create a whole area that all matches a certain data set. This happens to measure noise levels. So everywhere in this purple area has the same number of decibels. Everywhere in this red is the same, and so on. Topological maps are simplified to show you information on a particular topic. This is a metro map. It's an outdated metro map. It doesn't have the silver line, but all it's showing you is here are where the metro stops are, and here's where they are relevant to some key geographic features in order to locate yourself on the map. Everything extra has been eliminated. This is a quorum map. We won't see very many of these, but these can be very useful. They take complex information and simplify it. Basically, it turns your map into what looks more like a diagram. So if I take this map of Brazil, here I have rivers, I have the surrounding countries. It simplifies it down. It takes the basic outline shape of the country and then uses symbols in order to show me what the different areas are in terms of their climate, right? This is what this map is concerned with. I have humid zones, I have dry zones, here I have watersheds, here's the ocean. Okay, so you're simplifying that data. Topographical maps show you elevation, okay, based on ISO lines. Maybe you've seen like a 3D topographical map where the actual map is raised in different areas. You might use a topographical map in life if you were hiking. That would be relevant information. You can include both natural and man-made features on a topographical map. It depends on what you're interested in. We're going to look soon at a lot of cartograms. Cartograms show countries so their size has been manipulated to be relevant to the data that we're concerned with in any given situation. So what's important to remember about cartograms is that because countries are different sizes to start with, you need to think about their original size when taking into account the data. So for this particular map, here, up here, like this is Russia, right? We know whatever this data is, Russia has very little of it because Russia is a big country and here Russia is very small. India is a pretty big country, but we see it has a lot of whatever this map is measuring because it is pretty out of proportion to its original size. Same with China, Germany, pretty similar. The US, smaller than we would expect to see it. So we can make determinations about the data based on the size relative to the country's original size. Flow maps are super fun. It's like a combination between a flow chart and a map. The size of this line shows me how much of something is going from one place to another. These maps are particularly useful for things like trade and immigration when we're showing movement of goods or people around the world. So this one happens to be legal immigration in 2007 to the United States. So we can see where immigrants were coming from to the U.S. And based on the size of the line, we can see where there are more or less people moving from. Mental maps show perceptions. So here's the United States with the states labeled based on people's perception about what comes from those places. The maps that we made in class of the world could be considered mental maps. They showed some things about our perceptions of the world and what we know about it and where things are. Then we have cross-section diagrams, right? This is when I'm concerned with a particular place and I want to see what's going on, what the physical layout of it looks like. Transect maps show data along a continuum. So if I start in the natural area, here I have trees, right? I'm showing tree data. Here's how many trees there are. I'm moving in towards the city and I'm showing the change. There are more buildings, more roads, fewer trees, and so on and so forth. So I've picked a couple points of data and regularly sampled them along a line to create a picture of what the overall area looks like, or the way things change over a particular area. And lastly, we have space-time path maps. This shows movement through space over time in a graph. So this is not of a particular place. It is about movement of something from one place to another and how long it took to get there. But it is still considered a kind of map. We will look at a couple of these this year, very few. What it's doing is taking an XY graph and then adding a third dimension to it, adding that spatial dimension. So don't get hung up on this, but you do need to recognize what kind of map it is and make an attempt to read it if you see one. So that's it. Those are our kinds of maps. You need to be able to identify what kind of map is what and what it is used for. That is the goal here. We will practice making maps in class next time together. Thanks, guys.